Thank you, Ruben. So I'm here to talk to you about big data and fresh data, and how we think about making insights products out of data. So basically a product that's built solely for the purpose of helping people to understand what is going on Facebook. And as you'll see, some of those things are very subtle, and some of those things are the opposite of subtle. So I should start with a selfie, right? This is social media, so we always should start there. So this is me, I think the day I first started working at Facebook. I just moved across the country from Boston to San Francisco, and I had no idea what was in store for me. So that's the Golden Gate Bridge. And if you have questions throughout the talk, you can tweet at me. My Twitter handle is there, at @Sundram. So if I don't get to them after the talk, I can respond later. So I should tell you, what I came to Facebook to do was I was inspired by the amount of data we have. And I thought, what can I make out of this? And I found it takes a lot of different kinds of people to make data products. You need economists, you need engineers, you need people who are really familiar with the subtleties of visualizing data in a way that doesn't mislead people. And I think the most important thing there is the cat at the bottom who says no. There's so many ideas that you could have, but it's really important to stay focused on what you can do that will have real impact for your users. So I said this a couple of years ago, and I still believe it's true. All big data has to become small data to be visualized. So this seems, I think, obvious. And there's a couple of different ways that we can think about making big data small, which I will talk about. So this first project I'd like to talk about is called the Insights Wall. It's a way of really bringing home to people the scale of data that Facebook is working with, not necessarily in the most heavy insights, but in a way that sort of really gets them in touch with the impact that they're having on Facebook. I want to talk to you about this project I've been working on for the past couple of years called Chorus, which is Facebook's content insights platform. And finally, I'll just talk to you about what Facebook does as a company culture that allows us to really deliver very, very quickly on very ambitious products. So first I'll start with the Insights Wall, which I like to summarize as like, hey, we've got big data, so let's use a really big screen. Maybe this will help. And so what about a 6-meter screen? You can see this is, I would love to sit at this desk right in front of there and just look at all of this giant expansive data in front of me, but they don't let me sit there. And behind this panel is 20-some LCD panels. There's this little box called a spider, which allows you to, from a single machine, address all of these panels as if they were one, which is great as a programmer, because instead of thinking about a lot of different displays, you can think about one giant display and sort of forget the fact that you're working on a 20-foot or 6-meter wall. We have 41 megapixels, which has its own challenges, 36 touch points, which I will show you has also some of its own challenges, and as I said, the 20 individual displays are wired together with the spider, which makes it a lot easier for the programmers. So why would we do something like this? What's the purpose of having a 20-foot, 6-meter wall that you can kind of stand in front of and talk in front of? Well, I guess that's a kind of ironic question for me to ask, standing in front of a giant wall of pictures. But here's what our marketers have to say about this. This is part of an executive briefing center, which CMOs from lots of different companies come to Facebook to understand what can Facebook do for them. And so this screen, almost everyone who comes to Facebook gets to see their own data on the screen and really have it made personal for them. So for me, it's not just about data visualization, it's about data visceralization. It's taking something that's visual and really making a strong human impact. You can see the person at the screen is reaching out with their hand, and the scope of what is in front of them is larger than they can even sort of take in with a single glance. So that's a great way to make an impact. I'd like to talk to you a little bit about how such a project kind of comes together, because when I started, I didn't know how. It took somebody who really understood how are we going to get all of the panels together so that they meet at the edges perfectly. I'm the worst person to do this. I had a really hard time coloring between the lines when I was a kid. So if I had done this, there would be lots of gaps. We have a data visualization firm, Pitch Interactive, who worked on some of the more subtle kind of imaginative elements on the screen. And we have, of course, marketers who can speak for what is really going to have impact for their customers. What's the message that they want the CMOs to take away? Here you can see this project as it's coming up. This is all of the mounting hardware for the individual monitors. So we were sitting in this building for probably several months as we were doing the installation. So we started calling it the wall, because you can sort of see the wall rising over time. And here's the sort of the really great trick, if there is any trick here. This is Chrome in presentation mode over 20 individual displays, which is kind of incredible. It's the biggest web browser I've ever worked with. And because we are able to deliver all of the content for this wall inside of Chrome, you can use standard web development techniques for delivering content, which is great. But there are some challenges. If we want to really have impactful stories to tell CMOs, we actually have to have computed a huge amount of volume of data around who their customers are and what they've been doing lately, so how they're engaged with the brands. And that's, not something that you're going to click on a screen and have a query come back in seconds. That's going to take minutes or hours, but we don't have that kind of time. So we have an architecture here where we use Hive to sort of compute high-level aggregates, and then Presto, an open source database that we've released at Facebook, to do some of the queries that'll run faster on top of those Hive tables. Presto will finish in a couple of minutes, so before some important visitor comes, we can sort of cache what we need to show. And we have a whole UI for just caching data for important customers. You can see with 36 touch points comes its own set of challenges. This is Wes Grubbs, the lead designer at Pitch Interactive. He's rolling his entire body across this wall, and you can see all these white circles he's pointing to are phantom touches, and I think this is a really surprising way to test, but I think it was very effective. We spent a lot of time calibrating the touch screen so that it really had a responsive, natural feel to it. And a touchscreen that spans so much space is really hard to calibrate. So we would find at particular times of day, it seemed like there was a ghost in the room touching the wall, and we thought, well, what is going on here? It took forever for us to realize, oh, the sun at a particular time of day comes in through this hallway and bounces off the door, and the infrared from that light actually starts triggering some touches. So that took some calibration and actually just closing a window shade, a low-tech solution. With displaying real-time data comes certain challenges. If you have user-generated content showing on a screen, we have trending hashtags. Sometimes those hashtags aren't the most appropriate for families. So we have to address these issues before showing them to our most important customers. I'd like to just sort of show you the architectural diagram here. Some of these technologies you'll be familiar with, some of them less so. Tau is a internal Facebook database that we use. PrestoDB, I mentioned earlier. Having an in-memory database to drive an interactive product that uses a lot of data, I think is sort of becoming a very standard thing to do. And it really wouldn't be possible to have the kind of interactivity that we have without that in-memory database. In this case, it's Facebook Scuba. There's a paper about it, but it's not open source, to present that data to people. Tornado is a Python web server, and I think one of the most easy and compact ways to deliver data from a web server to a web browser is to use gzipped CSV. So CSV is comma-separated values, very easy to parse, very easy to come up with, and gzip is supported natively by browsers. So you don't have to do any complicated deserialization in your JavaScript at all. So this is very good bang for the buck in terms of development time and in terms of performance and size. You can see the visualization, I think almost everywhere is done with D3.js now, so I don't think that's a big surprise. What was a little bit of a surprise was, in order to drive the panel at acceptable frame rates, we ended up having to implement a lot of our visualizations using WebGL, just to get the performance that we wanted. So that was a real lesson for us. And at the end here, you can see a bunch of important looking people standing and looking interested, I hope, at the final product. And you can see in the very front, there's a Facebook representative sort of talking through their data on this giant screen. The next project I'd like to talk to you about is called Chorus. This is Facebook's content insights platform. The name comes from Greek plays. So the chorus in a Greek play is the character or a set of characters that explains to the audience what the people on the stage are doing. So this project is a project to explain to analysts what the people on the stage or Facebook's daily active users are doing in aggregate. So as you can see here, here's a Facebook post that I made. And this is a real treasure trove of both structured and unstructured data. So you can see my name. Along with my name, I filled out my profile, so there's some demographic information about me. You can actually see that there's a privacy flag associated with this post. There's a little lock there. So I made this post for only myself, and now I'm sharing it with all of you. There's hashtags in there. I can actually say explicitly how I'm feeling while I'm making the post. I can tag other people. I can tag locations. And even beyond what I explicitly say, we have topic taggers that can say, oh, this is a post about the Super Bowl. And this post is a positive sentiment. I posted a photo, and we can learn using our deep learning on images, what is this a photo of? It looks like it's a sunrise or possibly a sunset. That's a hard one. And a cityscape. And below at the very bottom, you can see likes, comments, and shares. So that's how engaged were people with this content that I decided to post. It's incredibly structured, and here it's all in one place. It looks beautiful. From a data analysis and data aggregation and reporting perspective, the beauty that we see in this one screenshot is sort of nowhere to be found. There are separate places for logging almost every single part of this post, and there are separate data streams which each of the different parts of the post will sort of wind up. So reassembling all of this data into a form where we can perform insights is actually a big challenge, and I'm going to talk to you a little bit about that. So what's the goal of content insights? We want an aggregated voice of people on Facebook. We want to know what people are saying right now. We don't want to wait very long. We want to be in aggregate, and we want to be anonymized so that people don't feel like their privacy is being addressed at all. We want to talk about what hundreds or thousands or hundreds of thousands or millions of people are doing, not what single people or a few people are doing. we want to be able to look at the topics that are computed from the text, not just what's in the text, and the sentiment that people have on those topics. And we want to be able to cut these things by demographics, so we can say, here's the difference between how men are talking about something and how women are talking about them, and how people's feelings about different topics may vary by gender and location and age. So here I have sort of a scatter plot, an empty scatter plot. I'd like to explain the axes first. Of insight speed, this is the amount of time it takes to compute what you want, and insights, I just called it insights, but it's really insights quality or depth. So as you go higher on the insights axis, you're being more thoughtful and really providing a lot more insight. So what we want, of course, is something that's very, very rapid and very, very high quality insight. So I think a lot of data products at Facebook start with Hive. Hive is open source, basically a way of looking at your HDFS file system with a SQL-like query syntax. And it's a really easy way to work with big data if you don't really care about having results anytime soon. So you can run thousands of machines for an hour or for tens of hours, and eventually you'll have a really good answer. So this system is able to take all of the different tables that are landing about what have people posted, what sentiment. We can run the sentiment classifier offline and tag every post with a sentiment. We can bring in our user table to figure out demographic information. We can run a topic tagger. We can do special things to extract and normalize hashtags. And we can actually have this piece called a term matcher, which allows us to say, if we're interested in all of the conversation around Big Data Spain, for example, let's look for hashtag BDS15. Let's look for the phrase Big Data Spain. Let's look for some other hashtags, like hashtag Big Data Spain, and some other things. We could look for specific mentions of accounts, like at Big Data Spain, or maybe even at Sundram, if that's a big part of the conversation. And matching every single post on Facebook, which is in the billions, with tons of these rules is a very computationally expensive thing to do, because analysts have, they want to have a lot of power to figure out, is this really a post about Big Data Spain, or did somebody happen to just mention the words big, data, and Spain in the same sentence? I don't have a good contrived example, but you can try and think of one. And it happens more often than you might think it would. So running these term matchers in real time is very difficult, and running them offline, in fact, takes a lot of CPU time, on the order of maybe hundreds of days per day sometimes. So we have this Hive system. It's working great. We've proved out our business case, which is that people are interested in what is going on Facebook. They want insights into text posts. So here's our goal, to remind you. And here we are with Hive. 3 days later, we have some really good answers for you. If we want to go to press and say, during the Olympics, here's the Olympian that had the most conversation on Facebook. 2 days later, maybe 3 days later, we'll be able to go to press. So this is really great insights, but they're not super timely. Not great. So let's figure out how to do some of these things in real time. As I mentioned earlier, regex searches over text are computationally expensive. There's some issues with how do you do stream joins in an effective way. Map joins are a little bit easier. They're key value lookups. And what I call compute joins, I don't think that's a standard terminology, but it's running a sentiment classifier, running a topic tagger, any kind of machine learning model that you want to use to generate predictions, running all of those things and integrating the output into your data stream. That's work, and you have to figure out where's the right place to do that work. So the next step was to say, okay, remember that beautiful picture in the beginning where everything was in the same place? What if we just took that data, right, when it was all, just for a brief instant, all in the same place, and just logged it there? One issue with doing something like that is that that's being generated on Facebook's web tier, right? This is a huge tier of machines where every compute cycle is very, very important. So any extra data that you generate, any extra RAM that you use, and any extra computation that you do is going to really impact Facebook's ability to scale. So we have to be very careful about this and very thoughtful about how we're doing it. And in order to not generate a huge amount of data, we decided, okay, maybe a 20% sample will be okay, and we can do this just sort of as code running on the page. We'll scrape everything together, we'll put it in this in-memory database called Scuba, and we'll let people run queries over the texts of the posts. And as you can see at the bottom of the slide, there's some charts that indicate somebody has done an interesting query and hopefully found something. So this is great, right? We are finally in a place where within minutes of a post being posted to Facebook, we can do a search and say, how many posts are mentioning Big Data Spain? And we will know, which is great. But we don't have anything like topics. We don't have anything like sentiment. We don't even have the engagement on that post. Doing those aggregations is not really super easy in this particular in-memory database. So we have moved closer to the y-axis, but we've moved a lot further down it. So we've got a ways to go before we can get to where we want to be. So this first attempt at sort of raising the quality of the insights that we're able to get in real time was actually started as a hackathon project that I did maybe a year and a half ago now, where I said, okay, Hive is going to be too slow. Doing everything in the web tier is going to be way too expensive. What if we can try and reassemble this post, all the guts of this post, afterwards? So we're taking a bunch of different scribe streams. Scribe is the transport layer that we use inside of Facebook, also open sourced. And we can actually say, okay, on some less important machines, not our web tier, let's run hashtag extraction. Let's run a sentiment classifier. Let's figure out how to do some kind of very simple stream joins so that we can bring in demographic information, location information, and our topic tagger is already running on every post in Facebook. Let's just take that cached data and bring it into this one big stream. And I was able to kind of prototype a system that had all of these different parts. It was taking some data that was computed at a daily grain, so our demographics data doesn't change that quickly, right? If I'm 21 today, I'm probably 21 tomorrow. 365 days, 364 days out of the year, that's true. Similarly, my gender is not particularly fluid, at least I'm not updating it on Facebook every day. So a lot of these things are fairly static, and it's fine to update on a daily basis. In the event term matcher box you see at the bottom, this is the sort of the engine that is trying to say, okay, is this post about Big Data Spain? And this was the real hard part for me, because running all of this sort of complex logic over every single post took a ton of time. So this is what really introduced scalability problems for me. So I was able to say, bring all of this data together, great, but can I tag this post and say this is about Big Data Spain? That part did not scale very well. So you can see, and this is the UI that you might that we put together to actually say, how can we tag a post as being about Big Data Spain, right? So on the very left, you see the event UI. This is where you might type in the hashtags, the mentions, any kind of topics that you might want to include. This gets written to a SQL database. And we can actually use that SQL database to generate programmatic UI on top of Scuba, so that an analyst can just say, hey, I'm interested in the Big Data Spain study. They go to the UI, and anything that's in that database just populates the set of charts that they want. You can see the custom stream joiner, that's from the last slide, running through the term matcher, which is coming directly from this event UI, and going then into Scuba. So this sort of works. The event matching, the term matching part is the weakest part of the system, but we're getting somewhere. So we're moving up the y-axis a little bit. Still not where we want to be. We're definitely behind Hive. We have limited capabilities, but we have more than we had before and more insights. So let's figure out how to get more capabilities into our real-time system. Here we have the next version of this product. So the architecture is getting more complex. The code is going from being a prototype that I wrote in Python to saying, okay, if we want high performance, maybe we're going to have to do some of this and roll up our sleeves and do this in C++. We are bringing in now image data. So we have an image classifier running on all of the images in addition to our topic taggers. It says wiki topics on the slide. That's because we tag Wikipedia topics from the top, top Wikipedia pages. And that allows us to disambiguate between Apple the company and Apple the fruit, in addition to sort of other things that may not be actually present as text in the post. So we, again, have hashtag extraction, but we're able to go a little deeper and say, okay, let's do some real text processing on this. Let's not just look for hashtags. We may want to do some kinds of normalization on the text, some sort of stop wording. Let's run word2vec on all of these things so we can actually have a really nice model of what the text is. Instead of just sentiment, we have an interface for machine learning. So anybody can plug and play their own text classifier into this system. So if they want to train a classifier that says if the post goes with a photo of a dog, so let's say if we can try and predict puppy pictures with puppy text, they could make and train and deploy their own puppy classifier using this interface. And our text matching is now being replaced with an event matcher, which is a fairly sophisticated piece of machinery that's capable of scaling really nicely to hundreds or thousands of different events going on at the same time. So not just Big Data Spain, but anything else that might be going on in the country or all over the world. Thousands of different terms, keywords, topics, hashtags over every single post that comes in, all tagged in a very scalable way. So this is our stream processing engine. We write everything out in Thrift, which gives us a lot of structure to our data stream, and it allows us to update all of our downstream dependencies very easily. I'm going to take a little sidebar to talk about the event matcher that I was talking about. So we actually ended up building a DFA to do this fast string matching, which has this really great property that it scales very nicely. So it's just as fast to process Big Data Spain as it is to process Big Data Spain and the thousands of other different things that people are tracking. It's a very nice piece of code. So we have all of this great data, this stream of really rich, contentful stuff, right? But we now have to figure out how are we going to present this to our users in ways that are going to inspire them, that are going to help them answer the questions that they have, and is going to do that quickly so that we have all of this stuff being tagged in real time, but we want people's queries to come back in less than seconds, right? We don't want people to be waiting for their insights, because I think the mode in which you explore data is very, very different if you're waiting for seconds versus if your queries come back instantly. If your queries come back instantly, you're operating at the speed of thought. You say, oh, I have an idea, let me click a button. Great, the UI updates. I have another question. If you're waiting for seconds, your flow is interrupted as an analyst. So you don't have that ability to just sort of say, oh, I have a question, I have another question, that's interesting. You say, I have a question, click. Okay, maybe I'm going to go check out, Hacker News or Facebook or something like that, and then they come back. So keeping people in the flow, keeping analysts in the flow is really important. This new piece on the right is called Kubrick. This is an in-memory database that we developed inside of Facebook that we're looking forward to open sourcing in the near future. This is basically the thing that allows us to do very, very fast slicing and dicing of huge amounts of data. So this is running not just on a single node, but on tens or hundreds of nodes, and allowing us to sort of say, okay, let's ask as fine-grained questions as we want and get answers back immediately. So as we were working on the stream processing engine, we were also working on this sort of this cubing engine, called Kubrick. So this works very nicely and complementarily to Scuba. Scuba allows us to sort of say, hey, here's all of our data. All of the raw samples are here. I can do queries over them. Kubrick says, what are the questions that you want answered? What kinds of queries do you want to do? I will make those things fast for you. It's great to have both, right? Why choose if you don't have to? So I think we're safely able to say, with all of these kinds of improvements, we are now sort of at parity. And this has taken a year and a half maybe, to get to the parity in terms of insights quality that we had in the very beginning with Hive. There's a ton of software engineering and solving of hard problems that had to go into delivering the same quality of insights in much, much lower time. What was really nice is that the finite automata that we coded was actually able to be called from Hive directly, so that we have exactly the same matcher running in our batch system and in our real-time system. And that system is that the matcher is so much more efficient, because it has to be for real-time, that in Hive we're saving hundreds of days of compute time. So this is being much nicer to everyone else who's sharing our clusters. So now I've talked a lot about the sort of technical underpinnings of the system, but I think what I stressed earlier is that it's really important to be in a situation where you're serving real business needs as you go along. So the reason these systems, the development was so incremental, was so that we could always be delivering some kind of real business value. Whether it's saying, okay, for keyword insights, we don't have that much data, but it's much faster. So if you want to talk about the number of people who are using hashtag big data span right now, you can. So we are able to now talk about politics and the elections in the United States, which I'll show you some examples of. We can talk about sports. People love to talk about sports, especially on Facebook. So I have some screenshots to show you of some of these things, and also for brands. How can we share this information with brands so that they can do a better job of reaching the people who are really interested in their products? We have the ability, as I said before, to have programmatically generated UI. So if we're looking at whatever this study is about, I think it's election day, we can see how many posts are going on and how that's changing, what the distribution of age and genders is, and what's the sentiment around these things, and the top hashtags. All programmatically generated from the system. So here I have a clip of, for the 2014 US midterm elections. This is super quiet. But you can totally see there's video, right? So 16 million Facebook users have posted about the election, and here's what they're talking about. These are the topics that matter the most to Americans who are voting in 2014. And apparently they're ranked in that order. When people are voting and they're saying on Facebook that they're voting, we can actually say, here's where they're voting in the country. And we chose to visualize this as if it's weather, as if there's a storm of democracy going across the country. And I think that was sort of kind of a quirky artistic choice that we made. But it's a way to demonstrate the power of the system, right? Once we have these insights aggregated and all together, we can generate interesting UI on top of them without a ton of work. So here you can see sort of the volume over time, and you can see the demographic breakdown as well as locations. Here on television, while President Obama is speaking, we can see what's trending right at the moment he's speaking. So community colleges, economy and jobs, and taxes were some of the things that the president was talking about during the State of the Union address this year. And so on ABC News, when this was being broadcast, people were able to say, oh, this is what my fellow citizens are talking about when they are watching this address. So we're not looking at what pundits think, some special person who thinks they know what everyone is talking about. You're actually able to say, this is what people are really talking about, which I think is incredibly powerful. Because we have a sentiment classifier, we can look at sentiment around political candidates and see, how are they doing? This is done in a partnership with ABC News and BuzzFeed. So you can say, draw particular conclusions about what is a candidate doing to drive their sentiment, and how is that changing over time. This is a fun one for me. A couple of friends and I put together this visualization of the volume of conversation around sports teams, football teams during the World Cup in 2014. So this was during the Argentina-Germany match. So these circles are all sized by the volume of conversation around each team and the players on that team. And you can see these little kind of colored rings correspond to the demographics in a very sort of artistic way, basically the different age ranges. And so we were able to project this on the wall next to the game and see, when somebody scores a goal. Okay, there was one goal in that game. When somebody scored that goal, you can see this huge surge, and the circles just get huge. This was pretty fun. So this is definitely not necessarily insights, but fun with data. During the Super Bowl, American football, we're able to look at the volume of conversation and engagement over time during the game. And you can see these very predictable peaks that you might expect to see. So halftime, there's a lot of talk about entertainment. Whenever there's a goal, that happens. But there's a huge fight that broke out at the end, which nobody would have predicted. And you can see that the engagement and the interactions around that event pretty much dwarfed everything else that happened in the game. It's another visualization of the same thing, and you can see Katy Perry, who's one of the halftime performers, got a ton of conversation. So the other part of this is we are now, because we have these insights in real time, and we have a huge audience, we're able to drive targeted ads to people who may be interested in hearing about Super Bowl-related ads. And one thing that I think is important to note is the Super Bowl is, in the United States, it's a huge event. It's 100 million people who are all watching television at the same time and engaging with it together. But on Facebook every day, there's 1 billion people. So that's 10 Super Bowls that are happening every day. 10 Super Bowls is a lot to process and to even think about. So we really need sophisticated, powerful tools to help people deal with that volume of data and conversation. Here's another clip, which, again, I'm not sure if you can hear the audio track. But this is looking at the sentiment around different sports teams. So this is, again, American football. Sorry, everyone. This is two teams that are based in New York State, the Bills and the Giants. And people are actually interested in how are the fans of the teams feeling about their team over the course of the season. And so I thought this was a really interesting way to think about, if there's a giant victory, the fans surge forward, and if there's a crushing defeat, they actually do seem to feel pretty sad about their team's performance. So really interesting human dimension. So with all of this topic insights, our ability to push ads in real time, we're actually able to power a topic data API that we can expose to partners who are interested in getting deeper insights into how to be effective advertisers on Facebook. So this is, I think, a blog post that was published just a few days ago that it was almost too good to pass up. This is looking at data around people who are watching a particular sporting event and who might be interested in a particular snack product, right? So the assumptions of the marketers going in was that they had a very young audience of men who were going to tune in right at game time. But what they found when they looked at the data was they actually have an older female audience who were tuning in 6 hours before the game to talk about the game on Facebook. So if they had gone with their gut, they would actually have missed their most engaged core part of their audience. So data is really able to overcome our assumptions about the world and inform better decisions. And so this is just a really great example because there's so many things where you think, oh, I know who's interested in this, and you're just wrong. So why make those assumptions if you don't have to? Now I want to talk a little bit about Facebook culture. Facebook is a kind of place that celebrates moving fast and building things. So I talked about part of this project being a hackathon. It went very quickly from nothing to something that kind of works. And Facebook actually develops a lot of its products, some of its core products, from hackathons. They start out as not really functional, but there's a core of a good idea that we can decide to develop into something really great. Done is better than perfect is something we say all the time. Get something out and then iterate, because you don't know what is going to need the most work and where the most impact is going to be from that work that you put into a system. Get something out and see what your users can tell you. There's always more you can be doing. The other thing is this. The first person to fly a plane didn't have a pilot's license. So inexperience is okay. I was not a streaming data person before I started working on these streaming data projects. I learned a lot from my coworkers, and some of my really experienced coworkers are still learning a lot every day. Languages change, algorithms change, there's tons of things to learn. At Facebook, we try to find our passion and build things. And I think that really sums up what we want to do. Here's what I've talked to you about today. Giant wall, how do you get insights in real time, and how do you move fast as a company? I'd be happy to answer any questions you might have. Thank you.
Thank you, Jason. It's been amazing every minute of it. If you guys don't have any questions, I have one for you. So how many of the open source bits that you explained on the workflow are being kept maintained, and do you plan to open up more open source?
Yeah, so the Kubrick, the in-memory database that I talked about that's powering our interactive experiences, we're definitely planning to open source that. Thrift is something that we have open sourced and that people outside of Facebook are using. For our streaming engines, those are currently not open source, although we've published detailed technical papers about how they work. Scuba is a good example of that, where there is a paper saying, here's how you can implement this kind of in-memory database. And I think due to the success of this JavaScript project, React, which has sort of taken the world by storm over the past year, I think Facebook has demonstrated a real commitment to open source stuff, and I think the people working on the front-end frameworks, the JavaScript stuff, have sort of lit a fire under the people who are working on back-end to say, okay, hey, if they can do it, why can't we do this? So they've really inspired us.
Awesome. Thank you very much. Okay, so thank you, Jason.
Thank you. Thank you for having me.